wait like 5 minutes because I see people still coming.
Okay. Before we start today's workshop, let's do some quick revision questions. Please answer the questions on poll everywhere, revising concepts from last week's workshop. And I already sent the URL through the chat. Please copy and paste the URL to attend the quiz. At the same time, I will present the same questions in the slides, so you may also type your answer through the chat. Both ways are fine. Okay, let's get started. The first question is, which data type does the input function return? Yes, as I can see, a lot of you guys already have the right answer. Input function will return string only. Yeah, so option A is the right one. Okay. The next one is, if x equal to 10 initially, what does this incrementation of x multiply equal to 5 give us? Remember, here is incrementation. It represents x equal to x multiplied by 5. So the output will be, yes, option C. You have the right answer. Yep. Okay, let us move to next one. What result does 30 modulus 7 give? Remember, the symbol here is not percentage, it's modulus. Yes, the right answer for this question is option C. Simple calculation, right? Okay, now we have our last one. This one is the simplest one among these four, I think. Okay. Can you guys see the questions on poll everywhere? Just 2 more seconds. Let me see. Okay, for this question, all of them will produce a syntax error, so no one will get wrong. At least you attend one answer. I will explain one by one. For option A, as you can see, it's obvious as a spelling mistake in print function. Should be print. And for option B, we have to keep print function in a lowercase. Otherwise, the Python 3 won't recognize this function. And for option C, someone forget to put the brackets on either side. And this will produce the invalid character in identify error. For option D, we need to make sure, as you can see here, we need to make sure the consistent on our codes. For these here, we need to change these, convert these single quotes into double quotes to keep the consistency. Okay, as I can see from the results, all of you guys done quite well for workshop 2 revision. So now, welcome everyone to our third MBSI Python coding workshop. Today, we are going to be talking about Booleans, Boolean logics, conditionals, and while loops. The main presenters will be Ian and Nick. Nice to meet you guys all. These slides are available under our MBSI coding GitHub repository, so you can review them if there's anything you need to revisit. Okay, just a quick recap from week 2. We have learned integers. Integers are whole numbers. It's a data type. And floats are just a decimal number. It's also a data type. We learn converting between one data type and another. By using the string function, we can convert integer file into string file. And also the mathematical operators. We learned addition, subtraction, multiplication, division, flow division, modulus, and the power. By using these operators, we can do calculations on Python 3, as you can see here. And we also learn overriding a variable with another value. For example, we can set variable x equal to 4 initially, and later we can set x equal to 8 to rewrite the value. And now if we want to print x, the output will be 8 rather than 4. The last thing we learn is incrementation. You have seen example in our revision questions. So here, the only thing I want to mention is always remember to assigning a value to variable before you use incrementation. Otherwise, this line of code here will produce an error. Okay, in this workshop, we're going to introduce some new concepts. The first part is Boolean data type, and we're going to learn Boolean expressions, Boolean comparison operators, and Boolean logic operators. Okay, and the second part, when introducing the principle of algorithm, we will use pseudocode and flowcharts to help us to understand. By combining the concepts from part 1 and part 2, we can move to our third part, conditional statements. And for our last part of this workshop is a part of loops, while loops. Some of you who have a background on programming may also know we have a for loop as well. And we're gonna introduce for loops in our last workshop, workshop 5, not in this workshop. Okay, let's get started for the first part, Booleans. We learned integer, float, strings, and today we have our Booleans. It's also a data type. Boolean is a special data type named after mathematician George Boole. And there's only 2 possible values for Boolean data type. They are true and false. If you already know binary code, it will be easier for you to understand Boolean here, because Booleans are similar to the binary code of 1 represents 1. 1 represents true and 0 which represents false, read by computer. As you can see the examples here, if we want to print the Boolean value true plus true, and the output will be 2, because true here stands for 1. And if we want to print Boolean value false plus true, the output this time will be 1, because false stands for 0. Easy to understand. Okay, and we also can convert other data type into a Boolean with the bool function. There's one thing I will, you guys need to pay attention to, is that a Boolean value can be assigned to variables, but it's not possible to assigning a value to Boolean. As you can see the examples here, we can set variable x equal to Boolean value true, and we can print our x. The output will be true. Yes, so nothing wrong. However, if we reverse the direction here, we set variable true equal to string x, and we want to print true. This time, there's no output because you already raised an error here. True and false are Python keywords. They are not built-ins, which means unchangeable. So always remember that. So far, you may have a question about why are Booleans useful? More specifically, why should we use Booleans? Well, Booleans represents the truth of a statement or expressions. As you can see these 2 statements here, they can be considered as a Boolean expressions. For these expressions here, 2 is less than 5, so the Boolean value for this expression will be true. And for these statements here, 15 obviously is obviously not greater than 15, so the Boolean value for this expression will be false. By using the Boolean expressions, we can solve a lot of actual problems by just using comparison. and the Booleans also the basic in our conditional statement part. You will see a lot of example later on that part. It will be not enough if we only use greater than sign or less than sign to compute Booleans under different or specific conditions. So I will introduce other comparison operators to help us. Comparison operators determine the relationship between two values. So here, as you can see, we have 6 types of operators. We already learned less than and greater than. We introduced the double equal sign last week. And I will make, and there's one thing you need to remember. The main difference between double equal sign and single equal sign is that double equal sign will test whether the value on either side are equivalent or not. Well, single equal sign only means assigning a value to a variable. That's the main difference. And also here, these operators here, this is how we represent not equal to sign in computer. And for last two, less than or equal to sign, greater than or equal to sign. They're almost identical to the actual mathematical symbols in reality. You just need to make sure that single equal sign always at the end. And by using these comparison operators, we can prompt the computer to compute whether it's true or false. And you will see some examples in next slide. Here, as you can see, because a single equal sign is not a comparison operators, which means this line of code here is not an expression, which raises an error here. And if we use double equal sign, it will work. And for these 3 examples here, this is how we use comparison operators. 5 is less than 10, so the output will be true. 5 is it equal to 5? Is not equal to 5? Obviously, it's not, so the output will be false. 5 is greater than 10? Obviously, it's not, so the output will be false. Also, we can assign Boolean expressions to variable. This example is identical to the first one I showed in the earlier slides. Here, we just simply assigning the Boolean value for this expression, 5 greater than or equal to 5.0. So the Boolean value will be true. And we assigning variable y equal to true, and we print y, the output will be true. So far, the comparison can help us to compute Booleans targeting specific conditions, but we can actually do more by using logic operators. Logic operator is a type of a Boolean expression that deals with the Boolean values. There are 3 types: and, or, not. And here you can see this is a brief summary of all possible output for these 3 operators. For and, if both Booleans are true, for example, we have true here and true here, and this whole expression here will produce output true. Otherwise, we get false. And for or, if at least one Boolean is true, let's say we have a true here, and this side we have a false or true. It doesn't matter. The output will be true. Otherwise, the whole expression will produce output false. Not only return the opposite value of a Boolean value. For example, we have a false, then we get true as our output. And we will see more examples in next slides. For and returns true only if inputs are true. This truth table here explicitly lists all possible input and output for a Boolean expression. As you can see here, if we have a variable x valued by Boolean value true, and the other one is false, this time true and false will produce output false. And if we have something is true, the other thing is also true. You can follow the truth table here, true and true. The output will be true. Okay, let's move to next one. Or returns true if at least one input is true. As you can see, we have a x equal to true and y equal to false. So the output will be true because true or false, we choose true as our output. And also, if we have something is 3 is not equal to 3, obviously it's not, so it's false. 12 less than or equal to 10, not, so it's false here. We have a both false on either side in OR. Then the output will be false. And this is for not. Not returns the negation of the input. As you can see, if something is not false, it means true. The output will be true. If something is not true, because here 3 is clearly less than 5, so it's true. Not true, we will get output false. Okay. So far, we finished our first part, Boolean data type. And now I'm going to talk about algorithms, which is basically how we use computer programming to solve actual problems. And I will use a flowchart to help us to understand. You've used the flowcharts before, maybe, but if you didn't, it's okay. A flowchart is very easy to understand. As you can see here, a flowchart always starts from a goal, and this could be our goal of code. Also, it could be a questions. And then how do I systematically make decision from my goal to achieve my goal? I need a condition. I need to set something here. In this flowchart here, the condition is it sunny? And by test whether the input meet my condition or not, I can go either way of this path to get my output. If it is sunny, yes, so I will go outside and I need the sunscreen as output. If it is not, I will stay inside. I need hot chocolate. Also, we can write down explicitly. Here you can see this is example of a plain language description for what your program do here. What I'm trying to say here is that we should think the goal of our code before we do the actual coding, and that's the main point of the principle of algorithm. By using the flowchart, it can help us to plan. It can help us to design the actual coding structure before we do programming. The goal of our code is what's the output I want from my code. And how to do that? I need a schema, and this is the algorithm. If you still haven't a clear figure of what is the principle of algorithm, I will explain more with another example. I'm not sure you guys will have such expectation before on coding. Before you may think is about 50% about actual syntax part and 50% about confusion. But when programming, actually, I can say it's only 10% about syntax programming part. It's about 90% problem solving part. Still, you may have some confusion as well, but it's better than you thought, right? And here, the problem solving is about principle of algorithm. If we spend more time on the problem solving and planning step, then we won't need to spend as much time debugging errors or on the construction of a code later on. A more understandable example is that the algorithm is just a plan to decide what your Pokemons should do in the whole combat to defeat your enemy at the end. Okay. After introducing flowchart, we also have another choice to design the algorithms by hand, which is pseudocode. As you can see here, pseudocode is a plain language description of what your code will do. Doesn't use syntax specific to any programming language, which means it is not executable. It can't be run by computer. It just like let you know what you will get from your code or your plan. You already have seen an example of this with the weather program we wrote earlier. There's no rules to write a pseudocode freeform. So here, never expect the computer will be smart to read your plan description and give you design output. That's ridiculous. Okay, here's another example of a programming flowchart. Some people find it easier to understand things graphically, yes. So here you can see our inputs A, B, C, where the program process information and make decision. And then we can get our output. This flowchart describes a program that takes 3 numbers in and to find the largest among these 3. Here we have input A, B, C, and then I need to set a condition to test whether to compare this value. So our first condition is that by using the comparison operators greater than sign, is it A greater than B? If it is yes, which means I will get my Boolean value true, I can go this way. Otherwise, I go in that way. If it is true, then I can go into this way, and still I have my second condition here to compare my value. Is it A greater than C? If still yes, which means if still true, I can go this way. And here I get my output A. Clearly A is greater than B, greater than C, so it is the largest one. Okay, so far we finished our first 2 parts. By combining concepts from Boolean data and the principle of algorithm, we can step into our next big part, conditional statements. And I think all of you guys will be able to construct a program just like this after you guys finished our 3rd part. Now I will pass my role to Nick. Nick.
Thanks, Ian.
Okay, I will start sharing all.
Yeah, I'll start sharing my screen. So can you guys all see my screen? All right. All right. So let's go on with conditional statements. So conditional statements are used for decision making within a program when depending on whether a condition is met. So as you can see below, here's the syntax of a if statement. The if statement is the most basic conditional statement. So as you can see, there's the if keyword over here, followed by a space, and then a condition or a Boolean expression. So some of the things that Ian would have just talked to you guys about, and then followed by a colon, an indentation, which is usually 2 or 4 spaces, and then some set of instructions. And the instructions can go on for multiple lines. You just need an indentation for each line. So in the case where we want some instructions to occur when the condition is false, then we add another conditional statement called the else statement. As you can see below here, there is an else keyword followed by the colon, and then indentation as well, and then instructions. So the else statement will run if this condition is equal to false. If it is equal to true, then instruction 1 will run. So here is an example of conditional statements. On the left is some pseudocode that Ian just went through. So on the right here is the program of the code. So here we've set Sunny equal to false, and if Sunny is true, then we want to print out these 2 lines. However, since it is false, we go to the else statement, and then we print I shouldn't go outside, and I'll make a nice cup of hot chocolate. And you see below, here's the output, and it performs exactly as we expect. There's finally one more conditional statement, and that's elif, or it stands for else if. This is used if there is more than one condition we want to test. As you can see over here, the syntax is exactly the same as an if statement, except for the different keyword elif. Otherwise, it's the same syntax as an if statement. We should note that the ordering of the statements or the conditions do matter. So if the condition 1 here is triggered or is true, then the program will not check for this elif statement or this elif or the else statement. So yeah, just have that in mind when we're doing conditional statements. So we can have multiple conditional statements put together. So this is called nesting. As you can see here, there's a outer if statement where we test for condition 1 is true. If it is true, then we go to its instructions, and in its instructions there are another if statement, so we check if condition 2 is true. If it is true, then instruction 1 will run. Otherwise, instruction 2 will run. And if condition 1 is false, then it'll go all the way down here to this else statement and run instruction 3. So here is an example of a nested conditional statement. So we've set age equal to 20. So if our age is smaller and equal to 65, and our age is greater or equal to 18, then we continue. And since our age is 20, this Boolean expression will be true. And then we go further inside. We check if the age is smaller than or equal to 21. And since 20 is smaller or equal to 21, we print out time to go to university, and we have the output here. If it wasn't smaller or equal to 21, then we would go to this time to go to work. And if it wasn't in between 65 and 18, if it was smaller than 18, we would print time to go to school, and otherwise we would print time to retire. So another concept that we'll be introducing to you today is loops. So if you wanted to print hello world 20 times, or if you wanted to print the numbers from 1 to 100, with the current tools that we've taught you guys, it would be really time consuming, or you would just have to copy and paste hello world 20 times to get the result you want. But luckily, Python has a really nice built-in function called loops. So what is loops? Loops are an efficient way to repeat code. There are 2 different types of loops, and while loops and for loops, and we'll be covering just while loops today, and for loops we'll cover in future workshops. So while loops, what does it do? Well, it repeats some instructions or a chunk of code while a condition is satisfied. Each time the loop runs, we call it an iteration. So if you can see the syntax here, it is exactly the same as an if statement, so except for the different keyword. Instead, we use while. So there's a while, followed by a space, followed by a Boolean expression, and then a colon, and then indentation and then instructions. So while loops are really useful when we don't know the iterations we want to go through. So an example of this is while a patient is still sick, we want to administer medicine. An important keyword that you should know when you're using while loops is the continue keyword. So this forces the loop to restart from the top. This is usually used when you want to skip something, and yeah. So on the left, we have the program or the code, and on the right, we have the output. So first we set n to equal to 0, and then we go to the while loop. While is smaller than 5. We increment n by 1, and we also check if n is equal to 3. So while n is equal to 1 and n is equal to 2, then this if statement will be false. So we won't reach the continue keyword, and we'll print out the current value of n. So as you can see on the right here, we have current n is 1, current n is 2, and then once n is incremented to 3, then this if statement will be true, and then you will reach the continue keyword, and then this forces the loop to restart from the top, or forces the next iteration, and therefore this print statement will not go through, and that's why you see that current n is 3 is missing, because we've reached the continue keyword, forces the next iteration. And then once n hits 4 and 5, then n will not be equal to 3, so it continues printing out the value of n, and once n reaches 5, then n will not be smaller than 5, so it breaks out of the while loop, and then it prints loop is completed. Another important keyword to use is break, so this forces an early exit from the loop. As you can see from the exact same example, we've changed the continue keyword to a break keyword. So when n is equal to 1, this if statement is false, so it performs as usually. You see the output, n is equal to 2. The current, it still prints out current n is 2, but once n is equal to 3, then this if statement will be true, and then it will reach this break keyword, and this forces the while loop to stop, and therefore you see print loop completed, and you don't see the further values of n. So an important thing to think about when using while loops is a thing called infinite loops. So this is when you forget to break out of your while loop and you infinitely go through your loop. This can be really dangerous and can stop your other programs from running, and can take a CPU to near 100% utilization. So we definitely want to avoid this. So this is some code, and on the right, this will be the output of the code. So as you can see, this is an infinite loop where current n is 0, and that is printed every iteration, and it seems like that the program will not stop until you force it to terminate. So how do we avoid this infinite loop? First, make sure your loop condition is well defined. So this would be this Boolean expression. Make sure that it's actually measuring something, or it's actually comparing two things. And yeah, make sure that it's not just set to true, or it's not set to 0 equals 0. Yeah, so just make sure that it's well defined. Also make sure that you're doing appropriate incrementing. So in previous examples, you would have seen that there was a n plus equals 1, where we were incrementing n by 1, so that eventually the while loop will break. The Boolean expression will be false. Finally, ensure that there's a break condition somewhere. So in the very previous example, we had the break keyword that was activated once a specific condition was true. And that's all from us today. We'll be going into our breakout rooms to go through the worksheets. Remember to fill out the feedback form.